Hello, everybody. I'm Marcos. This is me, and there's a tiny giraffe over there, which is very cute. I'm Marcos. I'm Malevo on GitHub and Twitter and most of the stuff. I can always use Taco, and I work at Continuum Analytics, one of the sponsors of the conference. So today I'm going to be talking about reproducibility. We're going to define what is a development environment, what tools or what things are out there that we can use to help us reproduce our environment, and what it would be really nice to have. So we're going to start with the definition, which at this point I think everybody knows what is reproducibility and why is this so hard for me to pronounce. But we basically want to make an experiment and want to be able to make the same thing or achieve the same result in another place, whether it is by the same person or by other people. In our case, since we're talking about software, we basically want the things to work. We want to compile, we want to build, we want to see the website, we want to see the same visualization. We want the thing to run. So in that case, we're going to go a little bit more deep on what is a development environment. These are a few definitions that I just found online in 2 seconds Google procedure. And it's a bunch of procedures, tools that for people who work in software need to build and deploy their software. These are 3 definitions, just found them real quick. No big deal about this. Then I also found there's a research from people from IBM, they made a more defined definition of what is a development environment. And they came out with 3 components: method, tools, enablement, organization, infrastructure, and adoption. From all of them, 3 of them only are more involved with people, like how are we going to have our team using or adopting our development environment? What is the organization tools that are going to help us provide that? And how are you going to encourage other people from the organization to use them? So I just crossed them up because I'm not going to talk about that. I'm just going to focus on, for instance, method, which in this case is roles, standards, checklists, templates, and development topology. In this case, I'm going to say that it has to do more with the way we work. Like, for instance, what guidelines are we using? What templates are we using in order to continue working? And checklists, and what are the standards that we use? This has to do a lot with I forgot. Anyway. We also have tools. Tools are, in our case, is mostly software. It's going to be the repo. It's going to be other tools that we use, whether it's for using Git or Bazaar or some tool like that for the version management or the repository. It's going to be the topology that we're using, whether if we are using some services outside or we're using everything local or we're using some sort of database or some sort of cluster, configuration. Infrastructure is a little bit more, it's like a weird mixture between the last 2. In this case, it's going to be software, going a little bit more specific, like what is the operating system? What is the database that we're going to be using? Different levels of control, and how are we going to be testing? Operating system is very important here because, people who are doing software, they already know that sometimes it's hard to compile the same thing not everything is cross-platform. So if something can work, it's only designed to be functioning in Linux. It may not work on OS X or maybe Windows. And if you are also doing mobile development, like in cell phones, that escalates real quick. And that's why it's the same. If the system is it's prepared to be working with Postgres, we cannot just plug in a MySQL or maybe Mongo. We have to be very specific about that, and there's no question about that. But in our case, when we work with data, going a little bit more on our use cases, I just point a few things that we usually do. Like, for instance, some people work in an environment where everything is production. Like, if you're not working on a product or on software, you're just doing like a quick notebook to prove something, and then you want to share with your peers, the notebook is production. As soon as you're done with that, you're going to just publish it somewhere, whether it's GitHub, whether it's NViewer or Anaconda.org. That is your final product. You can also be working in an environment a little bit more traditional, where you do have the development environment in your computer. You have a testing environment somewhere else, and then you also have production, which may be another platform. If you're working in Windows, you may be deploying in Windows, or maybe in another, I don't know, in Linux. So those are things you're going to be thinking about it. It's definitely multi-language. Right? Nowadays, just saying that I can only write Python, it's obviously not enough. At some point, you need to write SQL. You might need to write R, Bash, Batch. There's so many languages that it's very hard to keep them in mind. We also work in different configurations. Some people just work locally. If you have a few, not so much data, you can just download it to your computer and work from there. Some other people have like so much data that they can't do that, so they work mostly in the cloud. And that can be, for instance, using a cluster. A cluster in the cloud, whether it's the cloud like Amazon or Azure, or whether it's the internal cloud in your organization. And some people also do a little bit of both, where you have a lot of data, but you have the option to just sample the data and just take a few chunks of data, download it to your local workstation, and work from there. So this. And of course, how much data do we have? Some people just gigs, terabytes, or just whatever is coming after that, petabytes, and we'll know how can that go crazy. So after all of those, after a few definitions, what do we actually want to reproduce? I think one element that for me is very important, especially if you're working in a team, are coding styles and documentation styles. Like people, you want to have people working and writing the code more or less the same way, so it's more readable for the rest of the team, and you have more people who are being able to work on maybe add value to your software. Of course, this is the most common thing that when we talk about environments, which is basically the dependencies. Like we just say, okay, I'm going to need Bokeh, or I'm going to need Django, or I'm going to need, I don't know, Pandas or some other library. But we also have to take into account the database, whatever database that we're using, if we're using it or not, or what's going to be the source of our data. We also, and this is something very important for me, is configuration files and environment variables. It's something that we usually forget, but not everybody has the same installation of Postgres or the MySQL. They have just little customizations that we need to share across our team or across whoever wants to use that. So that's something that is very easy to forget, and we should always keep it into account. Sometimes we also want to share data, especially if you want to publish something in, I don't know, in NViewer or in GitHub. But there's no consistent way to share data, so I just omit this for now. And lastly, I just named these keys, which would be like Amazon keys, Azure keys, SSH keys to our own servers, or any kind of file that has it needs to be secure. For coding and documentation styles, there's a lot outside. There's a lot of guides, there's one called PEP8, which is like the one that is included in Python. There's a tool called Flake8 that's going to help us evaluate our code if you are complying to that guide or not. There's also one from Google, which is called Yet Another Python Format. And we also have these kind of guides for other software, like JavaScript or Ruby or whatever programming language that we're going to use. We do have some styles. We can use tools like linters to help us take a look if we're being compliant to the style. And there's other tools that I didn't add that they basically, yeah, this is pretty much it. There's also IDE configurations. If some people are using tools like PyCharm or I can't think of it, Eclipse, they usually, you can make a configuration. You can attach the configuration to your repo. So everybody that's going to have access to your repo has access to the same configuration. And in that case, they can be using more or less the same tools from the IDE that you're using, which is, I think that's very handy. For the people that don't use IDEs, they like more raw system like Beam, Atom, or maybe Sublime Text that it's very popular right now. There's this tool called editor config, which basically it allows you to add a configuration file for your repo where you say, I want the indentation to be 4 spaces, and I wanna add, I don't know, every file that is Python, I want to have 4 spaces indentation. For JavaScript files, I want to have 2 spaces, or whatever you want, whatever styles you define, you can define them in your repo, so you can share that with your team very easily. And in case you're working with documentation, there's tools like Sphinx in mkdocs in Python that, as long as you respect the structure they provide, you can compile it from there. So that's also going to enforce the people who work with you to write a well-formatted documentation. Again, one of the most important things is always dependencies. Whether it's database, we usually have to take into account installation instructions, which they're very tricky because they're not the same whether if you're using Windows, Linux, or OS X. So if you want to have your team having access to your deployment environment very quickly, you should document the steps that you're taking to install the database engine. You also want to share the schema and the configuration or dummy data in case you need it. An easy way to do those things is there's some tools that provide migrations. Like, for instance, Django has a system of migration, so you can just attach all of that to your repo, and as soon as any other person wants to use it, they can just enable and have more or less the same configuration as you. Actually, the same configuration as you. You can also use software as a service. And you can use a database provided at Amazon. So you just ask the people to connect to that database, so nobody has to worry about how to configure or do anything else. There's a lot out there, and I think they're kind of affordable. So you can also use makefiles or bash scripts in order to help people with installation. Makefiles are very handy if you're using Linux or OS X. If you're using something like Windows, just to think about batch files, which I'm not super familiar with them. And lastly, the new thing, Docker background is when you want to, this is like super cool. You can have a reproducible environment container in a new machine. You basically, in Docker, you have a container. Container is like a process that's basically running another operating system where you can have your own MySQL or your own whatever database you want. And whoever's installed that container can have the exact same thing as you. The only problem with this is that you're basically adding a little bit more overhead. You sometimes need to virtualize. But it's definitely something that a lot of people are using right now, and I think it's pretty fantastic. And always try to automate as much as possible. That's going to help people not make mistakes. Then when we talk about libraries, especially in Python, I think we have like 2 big options. There's one more, which is easy install, but I don't know how broadly used it is. So in this case, I only focus on pip and conda. I'm pretty sure everybody here are familiar with this, at least these 2. But with a tiny comparison, pip is basically the most well-known. It has a lot of packages. There's so many options over there. And on the other hand, conda is more focused on data. So that conda is maintained by Continuum and also by the community. If you're familiar with Anaconda, is the tool that we're using to build Anaconda. On another aspect, pip, since it's Python, it's multi-platform, but you're not sure that the library that you're installing is going to run in another platform because you just don't know that. It's never been built. That's not always true now that we have tools like Wheeler that we basically download pre-compiled packages, so they can be cross-platform. On the other hand, we have Conda, which is multi-platform because we build. If you want to build the packages across, if you have people using Windows, you can just build it for Windows, and that's going to guarantee that it's going to work over there. One is a little bit faster than the other one. That's also not true if you download packages already compiled. And they both work. They're both including Anaconda, so you can just use it. I'm going to do that. So, in the case of pip, how do we grab all the dependencies that we are using it, and how can we share them? There's a subcommand called freeze. We basically call pip freeze, point that to a file, and we end up with all the list of dependencies. It's usually a good advice to, whenever you want to start a project, start fresh. Like create a new environment. You can use virtualenv or pyenv if you're using Python 3. So you can start fresh, and you're sure that the dependencies that you're listing over there are the one that you're going to need to run whatever you're using. And this is like a little bit of advice. Like in this case, I do think that the specification it goes too far. Like I know that I need request 2.8. I don't know if I need request 2.8.1, because the last digit of the version is usually the bug fix release. So I usually want the latest as possible. So my advice is always to take this one out. Like I want 2.8. I don't care about the bug fix release. But if you want to be super specific, you can of course add it. In here, there is instruction in order if you want to create a new environment and start fresh, as I was saying. In the case of Conda, it's more or less the same. We use a subcommand called env, which is going to extract the environment, and in this case, it's going to send it to a file. I have a very confusing name. That's the name of the environment. Oh, that's wrong. And then when we take a look at the result, it's again, I think it's like it's going too far. Like I don't always need the build number, but I may just use it or not. I usually just remove these guys. Another thing that I think is very inconvenient from Python when you use these kind of tools like export or freeze is that it's always going to extract all the packages that I have installed, like all of them. So some libraries have specific dependencies for Windows or specific dependencies for Linux. And if I extract all of them, those libraries may not be, I won't be able to install some of them in another platform. So I usually don't recommend people to do this. I think it's so much better if you curate your own requirements or environment YAML file by your own. So every time you install something, you say, OK, I'm going to use Jupyter. So you install Jupyter, and you add it here by hand instead of adding with all the dependencies, because you don't know what you're actually adding over there. There are these tools that I think is very convenient. They look in the code, all the imports, and they try to guess what are going to be the dependencies. So if you already been working there, you don't remember what you install, I think it's worth to give it a try to this piprex and defrost. Seems super handy. This is a tool that I made, which is it's like an alternative to conda environment. The difference is that it's going to install all the dependencies in whatever directory that you're standing on. So you can encapsulate, or as I want to say, you're going to create like a pill with all the packages. And for me, the cool thing about this is that I can just remove the directory that I'm creating, and I don't have anything. I don't have anything else. It's super easy and clean to make it disappear. Well, notebooks are like super popular among this community, so I just wanted to show some tools that we made. Whenever you start working in a project, we first install whatever we want to use. We work on a notebook. This is how you fire a notebook. And if you want to share this, we have this subcommand attach that basically is going to take all the dependencies installed in the current environment, and it's going to put it inside the metadata of the notebook. So then with the notebook, you can do whatever you want. You can share it on GitHub, on a Gist, or using Anaconda or just email, whatever you do. As soon as you want to use it somewhere else, you can just create an environment from using the same file. This is going to go inside the metadata, extract the dependencies, and install it wherever you want to use, in whatever computer you want to use. So I think this is a very cool solution when you're working with a notebook and you want other people to take a look at the same notebook. You don't need to add any other file. Just ship the notebook, and that's enough. The dependencies are inside the metadata. Are living inside the notebook. Other things that, as I was talking at the beginning, other things very important to share, to reproduce is the configuration. People usually use YAML files, ini files, or JSON. Whatever file you want to use, you want to make sure that you attach that to your repo. Or you want to make sure that people have access to them and they're using them in their own system. The problem with this is that we usually store this in, as I like to say, programmer's brain. Like, the leader of the project knows that the size of the block of memory for whatever database is 16 megs. And that's the only person who knows. We should always avoid that. So we should always attach it to the repo, document. And I also found this tool, AutoEnv, which I think is very cool. You can put a file I think it's .env in your directory, in your repo, with all the steps that you need. I don't know, if you wanna have some environment variables available, if you wanna make some configuration, if you wanna change something, you can put it over there. So as soon as you cd into the directory, this AutoEnv tool is gonna capture the file and it's gonna execute whatever is inside. So this also could be very dangerous, so I don't know. Be careful. And lastly, keys. I don't think there's any standard on how do we share like SSH keys or Amazon keys or passwords. The most important thing here is don't put it in the repo, especially if you're doing open source. Just don't do that. Can be very, very expensive, especially if you're sharing your Amazon keys over there. There's stories about people crawling GitHub, finding keys, and taking advantage of them for create their own instance. So be very careful about that. And I don't have any suggestion here, so just talk to your IT department. Some deployment systems have their own like UI where you can attach the keys if you want to deploy, like Elastic Bean or Heroku. Just, I don't know. This is very specific to the project that you're working on, and I just don't think there's a standard. And some conclusions. So I don't know how is your experience when someone new joins the team. I think in my case, it's always been painful. Like, it's always this new person, he or she is going to spend a day or maybe two installing everything, downloading the source code, getting the data, and getting up to speed. Just having the project running or building takes forever. I explore so many options, I just can't find any good solution. Especially when you have your team with everybody using OS 10 and someone shows up with a Linux machine, or the other way, or vice versa. Like you just don't even know how to install Python in that machine or something like that. So, and I just don't understand why it's so painful. This is my catharsis. I think that the people who's working with development or DevOps, they have all this stuff already covered. Like they can give you a machine with some sort of database, some configuration, and they can do that in minutes. And I think we should also be working towards that direction, to have like more standards way to share the configuration, more standards ways to share our development, to, I don't know, find the process. And this is what I have. Questions? Yes?
Could you show again about for using conda envs within an IPython notebook?
Yes.
Can you share these slides?
Yes, I'm gonna put it on my GitHub, but I'm gonna tweet about this like in a minute. So this is the key. Attach. That's basically gonna go to the packages that you have installed, and it's gonna grab a list and put it inside the metadata.
So if you have a directory where you have a single directory of IPython notebooks, and you want to use different envs for different notebooks, you would attach them to the specific notebook via conda attach.
So this is the name of the environment. So you can totally do that.
Okay.
So you can say, okay, this notebook is gonna have this environment, so and this other notebook, other dependencies.
And do you know with that, could you tell from the notebook if you had forgotten which environment you would attach to it? Is there would be a way to inspect easily which one it is, or did you just...
No, I think you can use cat in that case. No, I don't think there's an easy way right now. But that's a good suggestion, though.
Lyft just open sourced a key sharing system they call it conda.
Oh yeah, awesome. From the cat thing. Oh, nice. Thank you.
I think there's a GUI element to inspect the metadata.
Oh yeah, when you're running the notebook.
Yeah.
Yeah, totally. All right. Yes.
So, on an earlier slide, you had, you crossed out the line about reproducing data.
Yes.
What was the reason for that again?
So I think there are people who are sharing the data across using S3, but sometimes your data is private, so you can't use that. And I'm not sure how you ship gigs of data. Like there's a lot of solution and there's no standard way. Some people use Dropbox, some people just put it in the repo. Some people give you S3 keys. Some people just ship you in a hard drive. Like there's so many, and I couldn't find any consistent way or more standardized way.
So you use you excluded it not because it's not something you want to do, but just because there's no standard.
Yes, indeed. All right, thank you very much.